this symbol, right, that's a Greek letter. And there's uppercase and lowercase Greek letters I used. Oh, I still have it. I printed this thing out of all of them upper and lowercase because people always ask me weird ones. This is a Greek letter. You know this one? Mu is what they say. And there's a picture with a cow with a little symbol, and it has this symbol, and it's funny when you're a math person because you read it and it says mu. It's moo, and it's funny. And no one else gets it.
Delta.
Delta. Triangle. There's a lot of, we use Greek symbols in math. Someday you're going to go to college and you're going to join a fraternity or a sorority and you're going to have a delta in your little letters and you're going to be like, oh, delta, sigma, whatever, alpha. And then you're going to forget all about that actually is an F symbol as well. But sigma, there's a lot of sigma in fraternities. They're out of control. What we're going to do is not talk about sororities and fraternities. We're going to talk about that we can use this to mean summation. I'm already recording. If we want to talk about the sum of a sequence, we're going to use this symbol. So you need to know what all these things mean. First of all, that means sum, so that means add them all up. And then we read it as the sum of whatever formula's here from k equals 1 to n, and I'm using k here, but they can use whatever they want. Sometimes they tend to stick with k, j, and I, and I'm not a big fan of I because I feel like I is reserved for imaginary numbers, but whatever. So don't freak out if it's not k, but this just tells you where to start. Sometimes it doesn't start at 1. This tells you how many terms to do. So if I wanted you to add up the first 10 terms, it would say from 1 to 10. Could you just write out the first 10 terms and add them up? Yes. Is there a formula that can make that quicker? Yes. So you get to practice. Oh, the unfortunate part is I printed these for you, so you don't get to practice making your own sigmas today. Everybody. It's just like a pointy E, right? Everybody should practice once. Ooh, see, mine was not so good. You should practice making your sigmas. Oh, that's sad. Just like infinity signs, you just gotta practice. Theta. Theta is probably the one we use the most in precalculus, Greek letter. But we'll go with that. So when it says find the sum of this, you just need to know what it means and work out the numbers and just add them up on this one. So when it says start with 1, that just means plug 1 in for there. So do you agree if I plug 1 in for there, I would just get 3? That would be the first term. But I want to go from 1 to 5.
That means fifth term.
That means fifth term. So if I plugged 2 in there, 3 times 2 would be 6. If I plugged 3 in there, 3 times 3 would be 9. If I plugged 4 in there, 3 times 4 would be 12. And if I plugged 5 in there, 3 times 5 would be 15. Why am I putting plus signs? Because sigma means sum. So instead of just writing the pattern today, I'm adding up the sum of the pattern. How do I know where to stop? Because the 5 tells me I only want the first 5 terms. And then you just get to add them up, right? 45? 6 plus 9 is 15. 15 and 15 is 30. 42, 45.
You can start with
There you go. I should have done that. So 45 is the answer. Maddie.
So you just start with whatever A is.
Whatever I is. You mean whatever?
You said 3I equals 3.
I start with whatever formula is here. Right.
Okay.
And I plug this number into it. So if this would have been 3I minus 7, the first number would not have been 3, right? I would plug 1 in here and say the first term would have been negative 4. So this is kind of like your int formula that we've been doing, only put in here. Other questions of where that's coming from? How about this one? The sum of 1 to 4 of this formula. And again, it means just start by plugging 1 in there for k, and then 2, and then 3, and then 4. And luckily, we're stopping at 4. 1 to 100, that would be so fun to do, right? I'm going to show my work. So I'm going to say 2 times 2 plus negative 1 to the 3 times 2 times 3 plus negative 1 to the 4 times 2 times 4. I'm just replacing k with 1 through 4, and I'm going to add those all up. So that's just going to be negative 2. Be careful on your calculators. Negative 1 squared is still 1, so that's going to be 4. That's going to be 6 times negative 1 is negative 6. And that's going to be 8, which is 4. Is that true? Not so bad, right? If I asked you to add the numbers 1 through 50, that's where a formula is going to be helpful. Every year I give a question on a test that I ask you to add up large amount of numbers, and every year there are people that sit there and do it on their calculator and waste a lot of time, and then stress because they don't get the test finished because they don't use the formula. But you can do it. And again, just like what we did with sequences in 9-4, sometimes they're going to ask you to find the sum. Sometimes they're going to give you something like this, and they're going to say, you need to write the sequence using summation notation. So, you have to write a sigma. Oh, naturally.
You gotta make it taller.
I just don't even care.
Decrease the angle. Oh, you care.
That's how mine ends up looking.
Decrease the angle.
I'm bad at art.
There you go.
Or those of you that do the infinity sign and you turn your paper sideways, you can turn your paper sideways and make it M, right?
Yeah, with a B.
B at the end.
Or a W would be the top.
Here's where you have options, all right? I don't care what you use down here. I, K, N, it doesn't matter. I'm going to use K just because we did before. I'm going to start with K equals 1. I think that's a good place to start usually. And how many terms are in this sequence?
6. Yeah.
Thank you.
It's like I would answer this on a calculator. How many 6?
That's not a hard part to do. Start with 1, end with the number of terms. This is what we did yesterday. You have to write the formula for this sequence. So step 1, you have to figure out, is it arithmetic? Is it geometric?
That's fine.
Yeah, to get each one here, we're just adding 5. So this is an arithmetic sequence. So I can, off to the side here, I'm going to remind myself that the formula for the nth term explicit formula is the first term plus n minus 1 times the common difference. That's where they get this formula. Well, there could be some weird ones, but usually that's where you get that formula, is they're writing the nth term, the nth formula. So the first term in this is 8 plus n minus 1. My common difference is 5. And then this is why I said you should work it out, because it just looks better here. So I could say this is 5, I wrote n over here, but I wrote k over here. Those need to match, right? So if you want to keep it as n, you need to change that to n. If you want to use k down here, I'm going to change that to a k. Because if you put n up there, where does n come from, right? Do you follow me on that? So if you want to use, you can use n down here, and you can use n up here. You just need to make sure those are the same letter.
But if they're not the same letter.
Then it's wrong.
Okay.
And then this would be plus 5n minus 5, so 8 minus 5 would be plus 3. So lots of people end up using n instead of k because we're used to writing nth formula. That's it, that's the answer.
Oh my gosh, that's so pretty. Look at that.
Questions about that? We want to talk about how we can add these sequences up without having to actually add them up. And there's a formula. We can prove where the formula comes from if you really want. But if you have a finite arithmetic sequence, finite means it ends. It doesn't go on forever, right? Finite, infinite. Those are the two types of sequences. A finite arithmetic sequence, so it stops at n. There are 2 different formulas, just depending on what you have. But you just need to make sure you know what these letters are. N would be the number of terms. If you know the first term and the last term, it's really cool that you can add up the sequence of an arithmetic one where you're adding the same thing. You can just take the first term plus the last term and divide by 2 and multiply that by the number of terms, and that will give you the sum. Isn't that cool? You don't seem impressed. sometimes you don't know the last term, and so that's when you need to use this formula. These two formulas will give you the same answer. It just depends on what you know. If you don't know the last term, and it would be a lot of work to find the last term, that's where you can use this formula. You can take n over 2 times the first term, plus n minus 1 times d, which is really just the same as the top one. But you don't need the last term. You just need to know the number of terms, the first term, and your common difference. And we'll talk about maybe when it's helpful to use each one. Number 4 is just silly because we could just add this up on our calculator, but I just want to use the formula just to show you how to use it. Because on this one, there's only 6 terms, and we could just add that up even without a calculator. But if we use the top formula for this, what would n be for this number 4 here? N would be 6. So I could say the sum, I'm just going to say 6. And then I just take the first term, which is -7, plus the last term, which is 13, and I divide by 2, and that would be the sum of that sequence. If you just add them up on your calculator, that's okay too. This would be 6 over 2, which is 3. So I think you get 18. So look at the next one.
4 years ago.
It was like 10 years ago.
That one every 5 minutes in California.
It was like a big one. Honestly,
This one would not be as simple to just add up without using the formula. Could you add up 2, 4, 6, 8 all the way to 70 without a formula? Yes, especially if you have a calculator. 2, 4, 6, 8, 10, 12, 14, 15, 16. But on a test that my tests usually take a good amount of time, it's not a smart method to sit there and type on your calculator and add those up. This is where the formula is helpful. And again, I think the first formula is useful here because all you have to do to find the sum of this is take the number of terms times the first term plus the last term divided by 2. The question is, do you know how many terms are in this?
Yeah, there's 35.
This is the first term, this is the second term, this is the third term. Yeah, it seems like it's just doubling on the term, right?
Automatically makes
So
that
this would be the 35th term. We could use the other formula too if you want to. So then that would be the first term plus the last term divided by 2.
so it doesn't ever really
What's 35?
As long as you know what's there, it doesn't matter. And I'll show you in a second. I'll use the other formula just to show you in case you couldn't figure out what term it was. I'll show you that you could use the other formula as well.
1260.
Just to show you the other one since we didn't use it, let's say you didn't know that was the 35th term, or you just automatically picked the other one. I just want to show you that you do get the same answer. And notice that on the other formula, it looks a little uglier, but you just need the first term. Oh wait, you still need the number of terms, so I guess it's just silly. Why would you even use this one?
I was kind of confused.
It's the same answer, but you still need the nth term. I mean, you still need to know what n is. So the helpful part is, what if they gave you the formula? I don't know. You could still find it. I don't know. I think I like this formula better, but it does work. Do you want me to do this to show you that we plug it in? It's the same thing. On which one? 1260. You got to be careful on this. If you're typing this in all at once on your calculator, you have to make sure you use parentheses because you need to make sure you tell your calculator to add first and then divide, right? So I just took 72 divided by 2, which is 36, and you should get 36 times 35. All right, again, the key idea is there are 2 types of sequences, arithmetic, geometric. There's different formulas to how to add them up, so you have to make sure you pay attention to the direction or the formula itself. Again, key word here is a finite geometric sequence. There is something called an infinite geometric sequence that we will talk about on Monday, but a finite geometric sequence, which means it stops at some point, so we're multiplying each time. This one looks a little bit uglier, right? Notice they say you can't have a ratio of 1 because you would end up with 0 in your denominator, so that's not, you can't really add that up. But the sum of that is you take the first term times 1 minus r to the nth power divided by 1 minus r. So what if this was your problem?
What does the 8th power mean there?
Oh, what does the 8th power mean? This is where knowing that formula is useful. Geometric sequence. Yesterday I told you that the nth formula for a geometric sequence was the first term times r to the n minus 1. So notice on this problem, they've written the last term kind of like this to help you out a little bit. Notice that 42 is the first term, and what are we doing each time to get to the next term? Divided by 6, which would be the same as multiplying by 1/6, which means if this is the 8th power, what term am I on?
8, 9, 7.
It's the n minus 1, so if this is 8, that means this is the 9th term. Does that make sense? That's why they wrote it like this. So this is telling you it's the 9th term. So the sum of the first 9 terms, which we could write the sum sub 9, is equal to the first term times 1 minus r, which is 1/6, to the 9th power all over 1 minus 1/6. I used to make people simplify this very nicely, and I'm trying to decide if I want to make you do all that work. Oh, look, I didn't. I just gave up. You want to use your calculator correctly on this, though. Notice that these are getting smaller. Well, they're just getting really weird fractions, right? 1/6 to the 8th power, 1/6 to the 9th power is not a very pretty number. But you need to make sure that you're typing this in your calculator correctly. Anybody want a shot at an answer? They feel confident?
50.4.
I got 50.4. No, that's on my paper. Like, these are my notes. That's why I was digging in my binder. These are my handwritten notes. Not even on smartboard. So, I'm okay with that. Just to make people do all the simplifying with giant fractions. And
One day, there's going to be a time when kids don't even know what take notes means. So they're going to have like some laptops.
people still take notes on laptops. Like, I think if we go to, if we ever go to like having whatever, I think it has to be something that you can write on, you know? Like, it has to be something that you can still write notes on, because you can't type math notes all the time.
I saw something that said, there's one time, I don't know why they say roll the window down anymore. That's why it's roughly
True.
same concept.
I went to a conference last year, and the guy's concept was the last backpack generation. That this is the last backpack generation because future generations aren't going to have to take books home, right? Like, they're just going to take a tablet home or a laptop home, and they're not going to need backpacks. So, I don't think that's true. I think there'll always be books. My father-in-law worked at Donley's in Crawfordsville, where they like printed books, and when they first came out with like the e-readers, like, he was so upset because he was like, it's gonna lose my job, and there's never gonna be printed books again. And it's not true. Like, there's always a need for printed books. I can just keep these same old ones that have been there for years. So.
Then add all these to it.
What does say wrote it like this: find the sum of the first n terms of the arithmetic or geometric sequence. So you have to figure out, is it arithmetic or is it geometric, and then which formula to use, and then use the formula correctly. I think we're adding 3 each time, right? So this is where, here's a good example of that second formula, because if you try to use the first formula on this one, you first have to figure out what the last term is. And so this is where the other formula comes into play, that we could say to find the sum of this, we could take 2 times the first number plus, I don't even remember if that's, oh, I forgot my end over 2. This is how I decide when I let you use formulas, is when I don't memorize formulas. I don't make you memorize formulas. So this is where this formula I think would be better to use instead of actually having to work out the 10th term. Could you work out the 10th term? You could, and you could just add them all up. But I'm just going to say that that would be 10 over 2 times 2 times 2 plus 10 minus 1, and the common difference there is 3. And obviously you don't have to write all that down, but I just want to show you where the numbers came from. That would be 9 times 3 is 27. 155. Anybody else get that? And so I never actually had to figure out the last term in order to do that problem. So that's where the second formula is helpful. But you could still use the first formula if you did a little bit more work. One more. What about this one? Is it arithmetic or geometric?
Geometric.
And what are you multiplying by? Negative 11. And again, they tell you that n is 9, so that's helpful. And then you're just using the formula. So as long as you know which formula to use and you know the values to plug in, again, it's not that bad to do. So I'm going to take the first term, which is negative 1, times 1 minus, be really careful here, negative 11 to the 9th power. I'm just going to say that. 1 minus negative 11. This one, it works out okay because when you take negative 11 to the 9th power, you get a negative number, and then the negative and the negative cancel out. But if this would have been an even power, this negative would have changed to a positive, and that would have stayed a negative. Order of operations, you have to do the exponents before you could cancel out negatives, and I just wanted to remind you of that because a lot of times people make a mistake on that.
I got a giant huge.
Well, it's definitely getting bigger, right? Like it's going positive, negative, like the numbers are getting bigger, they're just alternating. So let's see what I get.
Negative 19.
1 minus
6,495,641.
You got negative or positive?
Negative.
I got negative.
Well, actually,
Not negative. And notice that's because the 9th term is going to end in a negative number, so there's going to be more negatives than positives there. If we would have asked for an even number there, it should have ended probably in a positive because it would have ended with a bigger positive number. But those numbers are getting bigger, so that's why it's very different than the last one when r was 1/6. When r is a fraction less than 1, like you get small increases in value. When r is bigger than 1, we get bigger values, and that's going to lead us tomorrow. Tomorrow we're going to talk about how do we add up something that goes on to infinity, and it's really cool that we can add to infinity. So.
Scared on tests when doing an answer like that. I'm like, that's not what I have to do. And then you take it out.
Remember that the plan is to have our Chapter 9 test next week, probably next Thursday, at the latest next Friday, which means you need to make sure you're getting caught up on homework. Hopefully doing these homework quizzes more often is helping a little bit. Monday, we'll do 9-5 day 2, and then we'll do 9-6. 9-6 is a rough one. It's proof. I should have printed your notes out. Look how much time we have. But, if you were not here yesterday,